Fuse.
I was set to set. It just turned on. And it just turned out to 65.
I do. I mean, hard. So you teach like bones and something like that?
Yeah.
I was kind of, I heard something mentioned about bones.
Oh yeah. No, I teach biomechanics. Oh, that is ugly. Wait a second. Oh yeah, that's cardiovascular biomechanics. So that's in the spring. Yeah.
I had a tibial torsion, which I had to get it fixed.
Oh.
And I had to wear that for 2 years.
Oh my God.
Well, each leg, not total, not like both legs.
I'm the one that emailed you about missing.
I wore tape.
Okay.
Yeah, I wanted to ask you, you posted like the recording.
I did. It's on
And they- okay.
Yeah. So I can show you that. So if you go to-
I checked yesterday, but I couldn't find it.
I forgot to post it this
I heard it wasn't too much, just like an overview, right?
Yeah, it's just an overview. Yeah, so if you go to week 1, so it's the link is.
Okay, all right, perfect.
Yeah.
Thank you.
Yep.
The first 2 weeks after that, I think I'm
We're good. Next Tuesday is that gonna be like one of the like ANSYS days that we're
No. So today's an ANSYS day, and then we do them every other week.
every other week.
Yeah. So next Thursdays, yes.
Okay. Okay. I just want to make sure because I might not be able to be like in class next Tuesday,
Okay.
and I was like, I didn't want to have to like miss ANSYS already. So
Okay.
okay, I think it'll work out though.
It never bothered me.
Whereas if I did that for Riverside, I would be.
That's right. And so if you, I'm gonna go ahead and paste this into the Zoom chat.
Probably won't see it though.
Yeah. I'll make an announcement again once the class starts. Yeah, but if you're in the class, you can download this PDF from the campus.
Can I post it in the Discord?
Yeah. If you want to do that, I think not everyone's on the Discord though. So especially the waitlist people, I think they're not on.
This is just on Canvas for people that are.
Yes, yeah. So if you're on Canvas, just go to the assignment page.
ANSYS, to access it, you type in workbench.
Yes, yeah. We'll go over that today. It's not the most straightforward software to use for sure. Yeah.
It's funny, it's like someone, when I downloaded it, I was like, where is it?
Yeah. Because it downloads like 20 different programs. Yeah.
He communicated to me before, so that's why. Okay. Yeah, some of this.
I have a question about, so for the Discord, do we have to type a who's doing that as well, or just?
You don't have to, as long as you, if you feel comfortable doing that, so. Oh, yeah, you don't have that, you don't have that in Zoom because you're not. That's.
Can you just email it?
Yes, I can email it. Or let's do this. Let me go to the Canvas site. And then let me add you to the course. So do you want to put your email address here? That way you can have both the Zoom and this.
I don't know what to do.
So it's gonna manually add you, so you should get an email to you can add Hey, Kevin.
Smells like dinner here. That's probably you and somebody else. It's stronger back there, actually.
Someone will have to do it because I don't have the file on my. I only have Discord on my phone right now. So, but if someone else is on Discord can post the PDF there, then that can work.
You put it in.
You don't need the PDF if you can follow along in class, and it's the same thing. Yeah. So the PDF just has the instructions. All right, it's 5:30, so let's go ahead and get started. All right, good evening, everyone. How's everyone doing today? Good. Excited to do ANSYS today? All right. So this is really early. Honestly, this is really early to do an ANSYS activity, but every semester I get complaints about, I wish we did ANSYS sooner. I wish we did ANSYS sooner. And so this is the 5th time I've taught this now. So I used to do ANSYS maybe in the 4th week. I got complaints. In the 3rd week, I got complaints. 2nd week, complaints. And so this time we're doing the 1st week. So this is literally the earliest we can do ANSYS. Okay, so I hope I don't get any complaints about this. Okay, so today is our first ANSYS activity, right? And so wait till after the course. And so we're going to be doing our kind of the most basic kind of ANSYS simulation out there. Okay? And so what we're going to be simulating is we have kind of this rectangular plate right here. We have a hole in the plate, and we're going to be pulling the plate in tension. And we're going to be seeing, what's the deformation, what's the stress going to be like in this plate when you expose it to these conditions. Okay. All right. And so because we're in the 1st week, we are in a bit of a little bit of an awkward position because I know there's quite a few of you still on the wait list. And so if you want access to the PDF instructions, you can download it from this Dropbox link, which I didn't think it would be that long and annoying, but it is. And so if you feel like typing that long URL, you can. But you can also just follow along. And so the PDF, and so what you'll see on the PDF is mostly just what I'm going to be repeating out loud. And so if you think that you can just follow along with my instructions, then it's the same thing. And so the PDF just has basically the same things I'm going to be saying, just with some pictures and some words. Okay. And so today will also be an interesting day too, because this is the first time we're going to be testing ANSYS on all of these lab computers. So if you remember on Tuesday, these computers are all kind of grand spanking new. And so we had to install ANSYS on all of these. And we've never run ANSYS on this many computers at the same time for these computers. And so, I expect some issues are going to happen, just kind of how it is. And so okay. I didn't expect that issue, but sure, Cortana, whatever. And so if you run into any issues launching the software with the licenses, just let me know. I'll be coming around, throughout the day to kind of help you out. Okay, and so our ANSYS activity today is a plate with the hole. Okay, and so the idea is that we have this rectangular plate. It has these dimensions. Okay, and so first thing we're going to do today is we're going to CAD this up. We're just going to basically draw a rectangle with a hole. Right, and so the dimensions are given to you here in the PDF, which I will go over in the lecture, so don't worry about it. And here are the specifications for the loading, for the Young's modulus, and the Poisson's ratio, which are all things that we're going to be doing in ANSYS. Okay, so the first thing we're going to do, and I hope this lab doesn't blow up yet, is we're going to actually launch ANSYS. Okay, and so for those of you who downloaded ANSYS from Tuesday, you'll probably notice that ANSYS downloaded like 20 different programs on your computer and you have no idea how to actually launch the freaking software, right? And so, if you go to your start menu and you go to where ANSYS is installed, and so if you're on a lab computer, this should already be here for you, okay? So it looks like this computer has 2020 and 2021, but we'll use 2021. And the program that you actually want to launch, go all the way to the bottom, is called Workbench, okay? And so Workbench is kind of like so all of those different programs that ANSYS is installing, it actually does use all of these for different things. But Workbench is kind of the program that organizes all of it. So Workbench is going to be kind of the main user interface, and that's the one that kind of organizes all the other stuff. Okay, so go ahead and click Workbench. Yeah.
I downloaded 2022.
That's fine. I expected 2022 here actually, so 2022 is fine. But we're mostly, with these softwares, what they mostly update in each version is just they add some additional bells and whistles. So the core functionality is going to be the same for all. So, and so whatever version that you have, it's going to work. Okay, so for those of you on the lab computers, were you able to launch ANSYS? Wait, one at a time. So is it?
It's like, love it.
So what is it? Is it complaint? Is it even on the computers at all? Is it? Okay, just ignore the warnings. Yeah, it's so if you get some kind of Windows Defender thing, just cancel it, right? So yeah, just send them your credit card info. That's fine. Okay, and so if you're able to launch ANSYS, you should be able to get a window that looks like this. And so and it takes a bit of time to launch just because ANSYS is kind of a heavy program. But is everyone kind of here with me right now? Okay. Raise your hand if you're not with.
I mean, I don't know why I opened up and it's so small, I can't even figure out how to zoom in on.
Okay, I'll come back to you because I think there's some weird resolution issues that I think it's a resolution issue. Okay, so here's kind of the main interface of ANSYS. Okay, and so the first place that we're actually going to look here is on the left. Okay? And so on the left right here, these are what's called the analysis system. So these are all the different types of finite element analysis you can run in ANSYS. And so you can see there's quite a few, right? And so on the one hand, so remember how to do this. Okay. On the one hand, we have things like you can even run electrical simulations within ANSYS, which is really cool. Okay. If you're interested in CFD, you can run fluid flow simulations. Okay. And so Fluent is the one that you would use for that. Okay. If you're interested in finding out natural frequencies, modal analysis is for that. You can run dynamic simulations, vibrations, all different kinds of stuff. Right? So ANSYS has a lot of really cool capabilities. We're only going to be using a small fraction of them because it's kind of the easiest one to do. Okay? And so the analysis system that we're going to be using most of the time in this class is called static structural. Okay. And so what that means basically, it's a structural analysis, and so it's some kind of mechanical structure, and it's going to be static, and so there's going to be no motion involved. Right? And so to create a static structural analysis system, you're going to click on static structural, and I find that the best way is to actually click and drag it into the workspace. Okay. And so as soon as you click and hold on static structural and you drag it to the workplace here, you'll see that it kind of highlights a square for you to do it. Okay, and so as soon as you click and drag static structural, it should create a new window for you, just like that. Okay. Okay, so was everyone able to create a new static structural analysis system here? Okay. All right, so let me go ahead and clear this. Okay, and so what we're going to be doing from here, and so the nice thing about ANSYS is that it kind of lays out to you very clearly kind of all the steps you need to do to complete a simulation. Okay, and so if you remember from Tuesday, we talked about kind of the general steps involved in a finite element simulation, right? And so step one of that process is to establish your geometry. Right? And so first thing we need to do is we need to generate a CAD file or import a CAD file that is our geometry. And so for this particular activity here, we're actually going to be drawing the geometry from scratch because it's pretty simple. Okay. And so, before we do that, this is really important. And so you guys, before we go into the CAD software, you need to right click on geometry and then go to properties. Okay. And from this properties on the right side, you'll see. For me, it's line 19. For you guys, it might be different if you have a different version. But the setting that we're going to change here is analysis type. Okay. And so instead of 3D, we're going to actually do a 2D simulation. Okay? I think this might be the only time in the class we do a 2D simulation. But the reason we're doing 2D is just to kind of keep it simple because it's our first time using ANSYS, and so we want to make sure it's as simple as possible. Okay. And so make sure that your analysis type is 2D before moving forward. Okay. And if you're not sure how to get to that menu again, you right click on geometry and you hit properties right here. Okay. And that's how you can open up this window. Okay. All right. And so after you set the analysis type to 2D, the next thing is we need to open up the CAD software. So we're going to right click on geometry and you're going to click on new design model or geometry. Okay. So ANSYS actually comes with two different CAD softwares. And so the first software is SpaceClaim, which is kind of a newer one. And so we'll be using space claim later on in the class, but for something really simple like this, I find that design modeler is a bit easier to use, okay? And so go ahead and click on new design modeler geometry. And then what that's going to do is that it's going to open up a new program where you can actually draw the CAD file. And while that's going to take maybe a minute to load up. If you get any warnings, just cancel them. That's fine.
Cancel or allow access?
If you're on your own computer, you can allow access to it. But I think for these lab computers, it can be, it's going to ask you for a password or something, which I don't know what the password is.
This is zoomed in. That's good.
Okay, that's good. That's good. As long as this one and the next one are zoomed in, then that's all right. That's good. Okay. Okay, so is everyone able to open up design modeler? So does your window kind of look what I have right now? Okay, great. Okay, so now we're going to draw the CAD model. Okay, and so I think most of you have taken CAD classes before, so you kind of know what to do. But this is probably the first time you've done it in this interface, and so let's kind of go step by step. Right? And so the first thing we need to do is, because we're drawing a 2D geometry, let's go ahead and draw that in the XY plane. Okay. And so the easiest way to kind of draw that is to set the XY plane is to go to the bottom right of your screen. Okay. And so the bottom right of your screen, you should see kind of the XYZ axis there. And what we're going to do is we're going to click on the Z axis right here. Okay. And then what that does is that it centers the view such that the Z axis is kind of pointing towards you. Okay. And so that's kind of a convenient way to kind of switch the view in this case. The next thing that we're going to do is we're going to change the units of our analysis. Okay. And so because our plate it's measured in millimeters, it would be convenient if all the dimension stuff are in millimeters. And so at the very top of the window, you'll see kind of a button up there called units. And so you're going to click on that units button, and then you're going to switch it from meters to millimeters. Okay. Right. And so after you click on millimeters there, you should have the check mark next to there. And one way that you can check to see is that if you look at this bottom part here is like a ruler, like a reference ruler for you as you're drawing the CAD model. And so the units for that ruler should be switched to millimeters as well. Okay. All right, so the next thing that we're going to do is we're going to start drawing. Okay. And so the way we're going to do that is we're going to click, if you on the left-hand side of the screen under tree outline, you're going to click on XY plane right here. Okay. And so that tells ANSYS that you want to make a sketch in the XY plane. And then after you click on XY plane, you're going to come down right here. Okay. So right here, this part of the screen. And then you're going to click on sketching. And so that's going to switch this left-hand side part of the screen right here to the sketching tools. Okay. And so again, make sure you click on left XY plane right here, and then click on sketching this tab right here. Okay. And then once you do that, you can see that you can start to actually draw some stuff here. And so since we have a rectangular plate, let's go ahead and start by drawing a rectangle. Okay, so go ahead and click on rectangle right here. And the way it works is that you kind of set the two corners. And so when you click once, and so go ahead and click on the upper left quadrant right here. Right, and then as you drag your mouse, you can see that you're drawing a rectangle. Okay. We're going to dimension it in a second, and so you don't have to worry about the size, but just make sure that you have a rectangle that kind of crosses all four quadrants of the Cartesian axis. Okay. Right. So was everyone able to draw a rectangle for the in the program? This part of the class always makes me feel like a kindergarten teacher. So was everyone able to draw a rectangle? Okay. Okay. All right. So the next thing we're going to do is we're going to dimension this rectangle, right? And so if you look back at the spec sheet for this one, you'll see that this rectangle has a length of 300 millimeters. Okay. And so we're going to have a length of 300 in this direction, and it's going to have a width of 200 millimeters in that direction. Okay. And so let's go ahead and add these dimensions to our rectangle. And so to dimension stuff, you're going to click on dimensions here in the on the left-hand side of the screen. And then you're going to click, we're going to keep general for now. Right? And then you're going to click on one of the sides of the rectangle. So let's start with the length. Okay, so if you click on one of the sides and then you kind of drag it out, then you're going to be able to set the dimension of the rectangle. Okay. And so this part here is quite different from SolidWorks. So I know in SolidWorks you can actually set the dimension here, but to actually set the dimension in ANSYS, let's switch this to red. What you'll notice is that this dimension here has a name. Okay, and so the name for this one, it's a little bit hard to see, is H1. And then if you go to the bottom left of the screen, you'll see that we have the matching name here, H1. And then the actual length right there, okay? And so to actually change the length of this side, you actually need to change it in this bottom left portion, okay? And so instead of, mine is about 79 millimeters, let's change this to 200. Turn numlock on. Okay. And so of course that's going to make your rectangle a lot longer. And so that's the length. So the length should be 300. Sorry about that. Yeah, so the length should be 300. Okay. And then now let's set the height. And so the height for the rectangle should be 200 millimeters. Okay. So we're going to do the same thing. We're going to use the general dimensioning tool and click on the vertical edge of the rectangle, bring it out. And then in the bottom left-hand side of the screen, we're going to change that from whatever it is to 200. All right, and so if you want to, probably your rectangle is a bit too big for your screen right now, so you can use the mouse wheel on your mouse to kind of zoom out. Okay. So to pan, it's annoying. So you have to hold down Control on the keyboard, and then click on the middle mouse, and then that's how you pan. Okay, thank you. Mm-hmm. Every software has a different button for panning. It's annoying. Okay. Sorry, actually that's fine. Okay, so was everyone able to dimension their rectangle? Okay. Okay. Okay, so next thing we're going to do, just to make things easy for us, because we're going to draw a hole in the middle of this rectangle in a second, is let's go ahead and center this rectangle on the origin. Okay. And so instead of a general dimensioning tool, we're going to click on horizontal here. Okay. And so horizontal dimension allows us to specify a horizontal distance. Okay. And so and so for this one, we need to click actually two entities. And so with horizontal dimension clicked, we're going to click on the vertical edge of the rectangle. And then we're also going to click on the y-axis. Okay. And so doing those things allows us to specify this. For me, it's called H3 dimension. Okay. And then we're going to set that to be 150. Okay, just to make sure that the rectangle is centered in terms of, in terms of horizontal distance. And then probably, as you guessed, we're going to do the same thing with the vertical one as well. So we're going to click on vertical. We're going to click on the x-axis, and then we're going to click on a horizontal edge of the rectangle. Okay. And then for that one as well, we're going to set that length to be 100. Okay, so that the rectangle is perfectly centered on the origin. All right. Any questions on anything so far? Great. All right. It's looking good. Oh, sure. Yeah. So for the so what we just did was we did some horizontal dimensioning, and so what we basically want to do is we want to make sure the rectangle is centered on the origin. So we're going to use the horizontal dimensioning tool. We're going to click on one of the vertical edges of the rectangle, and then click on the y-axis, and then set that distance to be 150, and then do the same thing for the vertical ones as well. Okay. All right, so now that we've drawn our rectangle, we're going to draw, and we've centered it, we're going to draw a hole. Okay, so we're going to go back to the drawing tool here, and then we're going to click on circle, because the circle is going to draw us a hole. And then we're going to draw our circle right at the origin of the XY plane. Okay, so go ahead and click on the origin. And then as you drag the mouse out, it's going to change the size of the hole. Okay. And so you can make the hole any size right now, because just like before, we're going to dimension it. And so as soon as you draw the circle, go ahead and switch it back to dimensions. And then go ahead and give it a dimension. So if you click anywhere on the circle with the general dimensioning tool, it's going to allow you to specify the diameter. And our diameter for this case is going to be 50 millimeters. All right. And so that's the geometry. We have one more thing before we close out of this. And that is to set the thickness. Okay? And so even though we're doing a 2D simulation, this 2D this 2D part right here is representing a 3D object, and so we need to specify how thick it is going into the page. Okay, and so the way we do that is go first. We're done with sketching, and so go ahead and click back on this tab right here for modeling. And then after you come back to the modeling tab, if you expand this XY plane, you should see that there's a new sketch right there. Okay. And so that sketch is the one that we just drew. And so to actually turn this into a 2D object that we can run finite elements on, we need to go to concept. And then we're gonna click on this option here for create surface from sketches. Okay. Because what we want to do here is we want to take our sketch and actually turn it into a surface that we can run finite element simulations on. Okay. All right, so go ahead and click on surfaces from sketches. Okay. And so if you do that, then the bottom left-hand side of the screen is going to change to a view where you can actually specify the properties of this surface. Okay. And so the first thing we need to do is we need to set the base object for this surface. Okay. And so for this particular case, we're going to set sketch 1 to be the base object. And so what you're going to do is you're going to click on sketch 1 right here. Okay. Make sure that the sketch you just drew is selected. And then you're going to click on apply down here in the bottom. Okay. And so basically what we're saying is that this surfaces tool, we're going to apply that to sketch 1 in our in our model. Right, and so if you did that correctly, what you should see is that under base object, you should see one sketch, and that one sketch is going to be sketch 1. Okay. All right, and then the other thing we need to do is we need to specify thickness, right? And so this thickness is going to be kind of more an imaginary thickness because this surface is actually going to be paper thin, but it's meant to represent a 3D object. And so the thickness that we're going to specify here, if you look back at the problem specs, the problem spec says that our thickness here is going to be 5 millimeters. Okay. And so we're going to set a thickness of 5 millimeters here. Okay. So that tells us that our plate is 5 millimeters thick. Okay. And once you do all that, you specify the one sketch and you specify the thickness. What you're going to do is you're going to click generate here at the top, which has the lightning bolt. Okay. Then once you do that, it's going to turn your sketch into a surface. Okay? And so you should see your plate, and that plate should have a hole in the middle. Okay? And if you rotate around it, if you want to rotate, you can hold the middle mouse click and then just move your mouse around. And that is how you draw a simple sketch. Okay? All right, so were some people able to get this in their ANSYS? I think some people are still kind of working on it, so I'll give you guys maybe a couple minutes. If you need my help, just go ahead and raise your hand, and I'll come around. Is it just Workbench? So when that happens, I think if you change some of the resolution settings of your computer, the thing is, like I've seen, you're probably like one solution that I've seen all 4 people or something. Yeah, so you kind of keep it with it and see what comes. That's kind of what.
Okay.
It's annoying.
Like there's already.
Yeah, I didn't. Download it. I need to download it, so.
So.
Yeah.
Okay. Yeah,
I was trying to find the file, but and then I went all the way to the bottom and it said set up. I'm like, oh, I'm supposed to set it up. It's a little wacky itself. It should have been on the top, not on the bottom. What?
So some of the
Oh, you should keep, you should go to the gym and carry the laptop and pretty soon you get so used to it. No, I'm just kidding.
So it's like.
That could be it too, but
Yeah.
I try to exercise as much as I can, so and actually because of that, it's almost like a straight person, so. Oh, it is.
Like it runs everything.
Oh, wait.
Make sure
Everyone good here? All right, Zoom people, how are you guys doing? Is zooming? A lot of people are zooming through this activity, which is good. Okay. Okay, so let's go ahead and move on. So it looks like people are in a pretty good spot right now, right? And so now that the CAD model is done, we can actually close this. And so you know, as long as your workbench is open, then you can actually save everything else. And so we don't need this anymore. So let's go ahead and close Design Modeler. Okay. And then now we're back in Workbench. Okay. And so we actually did forget to do one step before we jump into Design Modeler. We forgot to set the material properties. And so if I know some people have been moving ahead a little bit. And so if you haven't set the material properties, now is a good time to do it. Okay, and so to set the material properties, you know, if you go back to our problem specs, you'll see that we have two main material properties here. So we have the Young's modulus of the material, as well as the Poisson's ratio. And so we want to make sure that these are correct, you know, before we actually run our simulation. You know, that's gonna have a big impact on our results. Okay, so let's go ahead and to change material properties, we need to go to engineering data. And so let's go ahead and double click engineering data. And then you'll see that these are the properties that we have loaded already. So for the student version of ANSYS, which is the one most of you are using, it only gives you one material by default, which is structural steel. Okay. And so if you look at the material properties for structural steel, if you look at the, if you expand this menu here for isotropic elasticity, and you look at the Young's modulus, you can see the Young's modulus here is 2 times 10 to the 11th power. And if you look to our material properties here, that is not what this is, right? And so you can change the units for this. And so instead of pascals, to make it easier, because my brain is farting right now, you can change it to megapascals. Okay. So you can see here that, oh, it is actually the same. Okay, we're good. I'm thinking of a different activity where we actually change the material. Anyway, sorry. Okay, so our material properties are actually good, but you know, this is how you change the material properties. You know, we'll come back to this in activity 2. You don't have to, and so the units there are just for you just to see it, but it doesn't actually change the property. Okay, so the next step here is we're going to open up ANSYS Mechanical. And so ANSYS Mechanical is the program that actually runs the simulation. So to launch it, you're going to highlight over row 4 here, model, and we're going to double click on that. and that's going to open up ANSYS Mechanical, right? It's going to look like nothing's happening, but if you look at the bottom left of the screen, you can see that ANSYS is trying to start mechanical, right? Yeah, so it can be a little bit slow, and so ANSYS is not actually, if you kind of understood what was going on underneath the hood, you'll see that ANSYS is actually pretty fast, but if it's your first time using finite element software, it can be kind of slow. So just give it some time. All right, so when you launch ANSYS Mechanical, it'll open up a new window, okay? And once this page right here loads, right, and so it's going to try to sell you. That's what I always assume this was. It just tries to sell you something. It's like a pop-up, okay? So we don't need to do that. And so to close this window right here, you can kind of click on anywhere here on the left-hand side of the screen. Okay. And so where I usually like to click is I like to click on geometry. And so if you click on geometry, that should load up the CAD model that you just drew. Okay. All right. And so at this point, hopefully you guys are kind of picking up on this, but ANSYS likes to kind of keep, even though it utilizes a lot of different programs. And so we just use its CAD software. Now we're actually going to use a simulation software. What they try their best to kind of organize everything in the same way. So, what you'll notice in a lot of ANSYS programs is that you're on this left-hand side of the screen right here. This is where you can kind of see like an outline of your project. Okay? And so this is kind of where you can kind of see most of the general information. Okay. All right. And so the next thing that we're going to do here is we're going to mesh our geometry. Okay. And so actually, if you're following the PDF, you guys are actually following a little bit of a more difficult way to do this. And so there's a much easier way that I found out. Not that I found out, that I kind of relented and said that, we'll just use this way anyway. Okay. All right. And so if you click on mesh, okay, let me go ahead and adjust this a little bit. Okay. And so if you left click on mesh right here, what you'll see right away is that there's kind of a lightning bolt. Okay. And so whenever you see kind of a lightning bolt like that in ANSYS, that means there's something that you have to do. There's something that ANSYS wants you to do before you move on to the next step, okay? And so before we move on to anything that's down here, we have to kind of do something with the mesh, okay? And so first, let's actually generate a mesh. And so let's see what kind of mesh ANSYS will generate for us without us setting it, okay? And so if you right-click on mesh, and then you click on this button right here for generate mesh, it's going to generate a mesh for you in ANSYS, just kind of based on just the default settings. Okay? And so remember, the purpose of the mesh is to take this geometry right here. It may look like a fairly simple geometry, but even so, what ANSYS has to do is it has to break this up into much simpler shapes before it can actually run a finite element simulation. Okay? So I'm going to go ahead and click generate mesh. It's going to take just a second. Right. And so after you click generate mesh, you can see here that we've generated a mesh that looks like this. Okay. And so it's not the worst mesh in the world, but it's also not, it's okay. It's not a bad mesh. Okay, so was everyone able to get a mesh that looks like this? It may not look exactly like this, but something that looks kind of similar. Okay. Okay, and so what we're going to do is we're going to improve this mesh. Okay. Because the thing that stands out to me for this mesh is that the elements that look like this, right? Remember, each shape right here is an element. These are huge elements. So these are pretty big. Okay. And so, the analogy that I like to tell people is that, think of your finite element mesh as kind of like the resolution of a digital image, right? And so I think, generally what people understand is that, the more pixels that you have in your image, the sharper the image is going to be, right? And so, meshes are the same way. And so the more elements that you have, the more accurate your simulation results are going to be. Okay. And so generally we want to kind of pack this thing in with more elements if we can help it. Okay. And so to change the size of the elements and to make them smaller, what we're going to do is we're going to modify this setting right here for element size. Okay. So this is kind of the faster, easier way to kind of modify the element size for the mesh. Okay. And so this is really convenient when you want to change all of the elements in your mesh. Okay? And so for those of you that are following the directions on the PDF, what you'll probably see is I made you create like a separate object, and I made you change the size that way. That's really convenient for when you're working with assemblies and you want to assign different element sizes to different parts of your assembly. But for now, we just have one part, and so we're just going to do this really simply. Okay. Okay, and so you can see here that the default size is 3 times 10 to the minus 2 meters. Okay. I'm going to make this a little bit more convenient for myself and change the units. And so if you go to the top of the screen, okay, first of all, make sure that you are in the Home tab. Right, just like we did in Design Modeler, we can change the units for this application. Okay, and so meters are a little bit inconvenient here because we have kind of a fairly small plate, and so I'm going to change this to millimeters. Okay, and so you can see now that element size has changed to about 30 millimeters. Okay? And so I'm going to cut this down. So instead of an element size of 30 millimeters, I'm going to cut this down to, let's say, let's cut it in half. So let's say 15 millimeters. Okay. Right. And so every time you change the mesh size, you're going to need to update the mesh. And so after you change the element size here, you can go ahead and right click on mesh. And then you can either generate the mesh again, or you can click on update. Okay. And so it's going to take a second. And so you can see here with an element size of 15 millimeters, we end up with a much nicer looking mesh. Okay, so these elements are a lot smaller. And so this is going to give us better simulation results. Okay? And we can continue cranking this down. And so instead of 15, we can go down to 10. Okay? And so with an element size of 10, this is looking much better. So we can go down even more. And so let me take it all the way down to 5. I think that's as far down as I want to take it. Okay. Right, and so with an element size of 5, we get a pretty. This is a pretty handsome looking mesh, if I do say so myself. Okay, and so you guys can tinker with it, and so for this simple simulation, you should get pretty good results. Even with a moderate mesh size, and so you don't have to use 5. So actually, I encourage you guys to kind of experiment around with it. But was everyone able to get some good meshes on their geometry? Awesome. Okay. Okay. And so there's some other settings you can do with the mesh. And so but for now, I just kind of want to keep it simple because I kind of want to focus this activity on kind of just the bare bones of what you need to run a finite element simulation. Okay. And so as long as you can get a mesh like this, then you're good to go to the next step, which is boundary conditions. Okay. That said, we are going to talk about meshing quite a bit this semester because meshing is one of the most important parts of finite elements. And so there's a lot that you can do in terms of the settings, in terms of the element types, in terms of adding refinement. Okay. And the PDF actually goes through some of that. And so you're definitely free to experiment with that. But for now, I just want to kind of keep it simple. Okay. All right, and so the next step that we're going to do is we're going to apply boundary conditions. Okay, and so remember, if you remember from the lecture on Tuesday, boundary conditions define what kind of external forces are acting on your object. Okay, and so if you look back at the problem specs, okay, if you look back at our diagram here, you can see here that we have 2 main boundary conditions. And so on one side of the plate, you can see that this plate here is going to be attached to the wall. Okay, and so one way that we can say that is that this plate here is going to be fixed. And so the left side of the plate is going to be completely fixed. And then on the right side of the plate, we're going to be applying a tensile load. And so that's a load that's going to be pulling the plate away from the wall. Okay. And so this tells us that we have two main boundary conditions to apply. So we have one boundary condition here on the left, and then one boundary condition here on the right. Okay, so we're going to need to have 2 boundary conditions here. Okay. Okay. And so if we go back to the to ANSYS here, we open up ANSYS Mechanical. First, let's go ahead and apply the fixed support. And so to apply fixed support, you're going to go to Static Structural A5. You're going to right click on it. And then you're going to go to Insert. Okay, and so you can see here from after you go to Insert, there's lots of different boundary conditions that you can apply. Okay, so there's a lot. We're going to be going over quite a few of these. Okay. But the most basic one that we have to apply here is a fixed support. Okay. Okay, so let's go ahead and click on fix support there. Okay. Right, and so after you click on fix support, you can see here that we've added this fix support object. And then now what we need to do is we need to tell ANSYS, where we want to apply a fix support. Okay. Because it's not enough just to define, what boundary condition you want. You have to define where you want to apply. And so if you look back to our diagram here, you want to apply the fix support on that left edge. Okay. And so with fix support highlighted right here, we're going to go ahead and mouse over that left edge. Okay. Make sure when you're mousing over that, you only see the left edge highlighted. Okay. And then when you click on it, only the left edge there should highlight in green. Okay. And so with that highlighted, you're going to go ahead and click apply. And so that's going to apply that fix support on that left side. Okay. And so that takes care of the fix support. And so now let's go ahead and take care of the tensile load on the right. Okay. And so just like we did with the fix support, we're going to right click on static structural A5. We're going to go to insert. Okay. And here you have some options. And so, there's all different kinds of loads that you can apply here. Okay. And so which type of load that you apply, it kind of depends on the data that you have, okay, and kind of what's most convenient. And so let me kind of go back to the specs for a second. And so if you look at the line here for the load here is P, you can see that the units for the load here are in megapascals, okay? 1 × 10⁴ megapascal. And if you've seen megapascal before, you know that megapascal here is a unit of pressure. And so for this particular simulation, it's going to be most convenient to apply the load as a pressure. Let me go ahead and clear this out. Come back to mechanical, right? So I'm going to go ahead and right click insert and then go up to pressure. Okay. And so just like we did with the fix support, we first need to specify what part of the geometry we want to apply the pressure mode. Okay. And so for this case, we're going to click on the right edge. Okay. And so make sure you mouse and click over the right edge and you're going to hit apply. Okay. And then now we need to specify the magnitude. Okay. And so the magnitude specifies, how much force or what the magnitude of the force is that you're going to be applying to. Okay. But we're going to make one change here. Okay. And so what I find most convenient for, at least for myself when I'm applying forces, personally, I like to specify kind of each individual component of the force. And so I like to specify the X, Y, Z components individually. Okay. And so the way you can do that is you can go to this line right here called defined by. Okay. And instead of having this setting be normal 2, we're going to set this setting to be components. Okay. Right. And so by doing that, you can see here that we can set the X and Y components, right? And so we don't have Z here because this is just a 2D simulation. Right. And so for this one, our X component of the force, what was it again? It was 1 × 10⁴, and so that's 10,000. Okay, and so we're going to set a positive 10,000 there for the right. So let me pause here for a second. So is everyone able to kind of get to this point right here, specifying the boundary conditions? All right. All right, so we're almost there. And so let me just go ahead and finish up just because we're just about there, and then I'll go tour the class. Okay. And so at this point, we're technically ready to solve. And so we have everything that we need to run the simulation. We have our geometry, we have our mesh, we have our boundary conditions. Okay. And so we can actually click solve right now. Right? And it'll actually solve. But what we're going to get from that is actually not anything useful. And so, we want to make sure that we actually view the right results when we're done. Okay, and so to specify which results you want to see, you're going to right click on solution A6, okay? And then from here, you can specify what simulation result that you want to see, okay? And so there's lots of different results that you can specify here. So the first result that I almost always specify is total deformation, okay? And so this is going to show you how much your part here is going to deform, okay? So I'm going to specify that. Next, I'm going to specify a stress, right? And so I know a lot of you are interested in doing stress stress analysis. So this is how you're going to do it. And so you're going to right click on solution A6, go to insert. And then under stress, you can choose, lots of different types of stress here. Okay. The simplest one to look at is the von Mises stress. Okay. But you can do the other well. Right? I believe in the PDF it also asks you to do the maximum principal stress as well. Okay. But we can ignore that one for a second. Okay. All right, and so once you specify what outputs that you want, you can go ahead and click solve. Okay. And so click on the lightning bolt. And so again, it might look like ANSYS is freezing, but if you look in the bottom left here, so the bottom left of your screen is where you should typically look if you think ANSYS is freezing on you. Most of the time it's not, it's just thinking. All right, and so then after that, you go ahead and you can click on the results, right? And so each of these results here are going to show you something different, right? And so first, let's look at the total deformation. And so this is going to deform, right? And what to pay attention to here is the colors, right? And so each of the different colors represent a different amount of deformation. And so if you can see here, the maximum deformation that we get is 16.48, 848. You can see they are in millimeters. And so the maximum deformation that we get here is actually on the right side of the plate. And the minimum amount of deformation here is on the left. Okay. Right. Okay, so you guys can go ahead and play with this for a second. And then if you guys are having trouble, just raise your hand and I'll come around.
You got it?
Yeah, I think I was so small. I was like, the text was this big. So I was
Oh,
like,
yeah, that's what they were helping.
I got it fixed. So,
Oh, it's true.
it's tough.
It's like most.
Is your DPI like really small? Yeah. Just on the workbench. So I'll be able to type.
So you have to save it. Yeah, that's what I got saved. Anything. I'll come back. I looked online and I'm not.
Like your match has like a plus sign, if you look at more stuff.
So this is the files.
Next, it's just-
No, I have.
Honestly, it feels like you guys-
Media, that's why yours is different. It's because you set a more complicated match. Yes, he did a basic. So all he did was click on this, so then this went open, and then here, just change this. And then when you did that, then you would have to. So you just double.
Save this too, or is it separate?
So you have to, then you just take 5 in here, but then you have to go back here.
Because I'm finally starting it too.
Notice how you have more matching.
Yeah. Okay, yeah.
Versus ours.
Oh, yeah.
Yeah, you're right.
So, yeah, so we can actually go to application.
I don't really have that.
So, if you follow this, we did it. This is better for later. And you can set different matches for grid sizes. I was trying to do this now last night, and I couldn't figure out how to draw it.
Or change. This.
Because we put it in there, the geometry, I was
I
right.
had to do application.
I was like,
You had it
I
now.
did it in Kansas.
So that wasn't one thing, the very first time.
I've never.
It's the two boxes. Shaded exterior and edge, is the other one just shaded.
So you're using, I question.
Yeah.
I only know.
Thank you.
I mean. I feel like we need to know it very well. Yeah, but I do kind of regret it.
Okay.
Like 90%. But like, that's bad. Like, I was tired of like him doing vectors. What was your physics? Okay, so yeah, especially going back to like that one. It's like. We didn't really use much. I mean, I solved. That's one thing. Actually, that was my favorite part. Really? Did you? The couch.
Yeah, they want the other way?
Like, I didn't. No, like you look at where just was for that, but I didn't know. And then I took 430 here.
And then we have another guy who's.
Yeah, which one do you have it right now?
Yeah.
So it's going like this, not like this.
I mean, I was honestly.
Yeah.
I can break it.
I
And he has
just
like
one, yeah.
specialized.
Oh, yeah.
How?
Oh.
Just leave it all.
That's why I like this show now.
Robotics.
I've never. So I saw more I want to do the auto. She helped me once, but I never. Yeah, she. Oh no, yeah, I think. I just.
So that's what you took.
I dropped it. I was
So did you choose pressure, but it's actually the edge, you control the staging, the axis. That works.
So I like.
We just break them. So what did you do for that? So what did because when you choose fixed point, you hit it differently than.
So you're just like. You don't do it, I would say.
So we get
Oh, really?
No.
This part was
Making my brain work. When I'm supposed to be the one that's confused all the time.
I didn't really.
What's these two?
So somebody wrote those. And they simulated so that first they did it with like maybe no, I think it was like we're leaving our laptops and then the last group
I finally got it fixed.
I couldn't start it because my DVR was so, the text was so small, I can't read it. I was like, it took me 30 minutes to finally figure it out.
All right, Zoom people, how are you guys doing? So there's a couple things I want to talk about. For some reason, my mic is off or my camera's off. That's weird. Okay, can you guys still hear me on Zoom? Not that many people are on Zoom though.
Yeah, I'm here.
Okay. Okay. Well, you can't see me, but I'm still here. Okay. And so the other thing that you can do on here is you can look at the stress field. Okay. And so we're going to talk about this, next week when we're going to do a review just of solid mechanics. But whenever you take an elastic structure like this and you apply forces to it, there are internal forces and internal stresses that form within the structure just to make sure that the structure itself stays in equilibrium. Okay. And so you can see which parts of the structure here are under greater amounts of stress. Okay. And you can see here, and that's kind of the reason why we do a plate with a hole. You can see that a lot of the stress is concentrated on the edges of the hole right here. Okay. And this is really important because this kind of gets into kind of strength of materials. And so what tends to happen is that if the internal stress of the material exceeds its tensile strength or exceeds the yield strength of the material, then that material will break, okay? And so this is one of the big advantages of using finite elements, is that you can compute what these internal stresses are, and you can determine really easily whether or not your part is going to break or fail. Okay. And then maximum principal stress, you'll see that numerically it looks very similar to equivalent stress with a different pattern, but it's just a different measure of stress, right? And so throughout this class we'll be talking about the different kinds of stress that you can get in the field as well. Okay, all right, and so a few bookkeeping stuff, and so from here, if you look at the PDF, the next steps for you to do is I basically want you to tinker around with this and to produce some different figures. Okay, so if you scroll down to the bottom, right? Problem 2 here is to iterate on this. Okay, and so I want you to change some of the settings of the simulation and see what happens. Okay, and so the first thing is I want you to change the load. And so instead of, well, this is a typo, there should be 10,000 right here. And so instead of 10,000 megapascal, change it to 9,001 megapascal, so just over 9,000, right? And so if you change that load here, what's going to happen. So I'm not going to do it here. I'll let you experiment with that. Next is to change the size of the hole. And so to change the size of the hole, you would have to go back into Design Modeler and actually change that dimension there. Okay, and so to make the hole bigger. And see how that affects your results. Okay. Next is to change the mesh size. And so, if you remember the way that we changed the mesh size, we went into mesh right here, and we changed the element size here. Okay. So right now it's set at 5 millimeters, but I want you to change it to something smaller, and so you can go down to even 2 if you want. Okay. So I want you to change that mesh size, run the simulation again, and see what you get for the results. Okay. We didn't do refinement, so you don't have to worry about part E. And so, if you follow the PDF, you saw refinement, but I don't want you to worry about it right now because I want to keep this simple. And so the last thing I want you to do as part of this activity is to change it to triangular elements. Okay. And so if you look at this mesh right here and you zoom in on the elements, you'll see that most of the elements here are squares, basically, right? And so they're 4-sided quadrilaterals. Right? And so what you can do is if you go to mesh right here, and I want to see if you can change it here. Okay. And so what you can do is you can right click on mesh and you can add a method setting. Okay. And so what the method setting does is that it allows you to change the shape of the elements. Okay. And so you click on method. It's going to ask you to select a geometry. And so you click on the plates geometry. You say, okay. And then what you're going to do is under method right here, instead of quadrilateral dominant, you're going to change this to triangles. Okay. And so that's going to change your mesh so that instead of these quadrilateral square shapes, what you're going to have instead are triangular elements. Okay. And so you can see here that now our mesh is made up of triangles. And so I want you guys to give that a try, run the simulation, and then report on what you find. Okay. I'll spoil it a little bit just so that so that people aren't panicked. And so for this particular simulation, because it is fairly simple, I think this is the simplest simulation we'll run this year or this semester. You're not going to see that much of a difference between the quadrilaterals and triangles. And so don't expect anything big to change between them. Okay. And so I mostly just want to make you aware that you can change the shape. And then later on this semester, when we talk about meshing and all the different things you can do, we'll talk about when you want to use certain kinds of meshes or not.
Returning in bulk or just the final?
So what I want you guys to do for each of these changes, I want you guys to take screenshots of the deformation and the stress field. And so if you read the PDF here, it'll show you what you need to turn.
And then if you want to turn that into the PDF of all the screenshots.
Exactly. Yeah. So if you read through the PDF here, then it'll tell you
How to turn it in.
exactly. So there are questions I want you to answer and different screenshots I want you to produce. So it's all outlined here in the PDF. Okay, and so after that, then there's also some short answer questions. And so this relates to some of the conceptual stuff we talked about on Tuesday, okay? As well as some conceptual stuff we learned from this activity today, right? Right, and so the last, so this is important here. So the last thing I want to show you guys before you go is how to save your results. And so I always forget this every year, but I told myself I'm not going to forget it this year, okay? And so the way saving works in ANSYS is that you want to save it from Workbench, because Workbench is the program that kind of manages your whole project, okay? And so I'm going to go ahead and close Mechanical for now. Okay, you want to make sure everything is closed except for Workbench. Okay? And you want to go to File, right? And so the tempting thing to do here is to click Save As, right? And so if you click Save As or Save, this will save the project on your computer, but I'll show you what happens. Right? So let me go to Documents just because it's empty. Okay. So ANSYS activity 1. Okay. And so remember, this is under saving. And so if you look at the file format for saving, it's going to save your file as, or save your project as project files. Okay. And I'll show you what that means in a second. Okay, so it's done saving. And so if you go to my documents, which is where I saved it, okay, you'll see that it saved, this file, which, most people think reasonably that this is the ANSYS file that you can save, and you can load this on a hard drive or put it on Dropbox to work. Okay, but what you'll see is that it also produced this folder right here as well. Okay. Okay, and so both of these things actually contain your ANSYS files. What's annoying about this is that even if you transfer both this folder and this file, and you try to open up this project on a different computer, it's going to give you an error, because what it's saying is that it's not able to locate the files that are associated with this project. Okay, and so the reason for that is that once you kind of make an ANSYS project, it kind of makes what we call like a hard path on your computer. And so wherever these files are right now, which are in documents, users, blah, 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 it's going to look for the files in that location. Okay, so it's basically going to look for this path right here. And so if you move this folder to another computer, you're never going to have the exact same path to those files. And so you're never going to be able to open up your ANSYS project again. Okay? And so the better way to save is actually to go to File and then go to Archive. Okay, so what Archive is going to do is going to basically run a file compression and then compress everything into a single zip file. Okay, and so I'm going to do the same thing, and so call this compressed ANSYS activity 1. Okay, and so it's going to ask you what you want to archive, and so you can just leave it as the defaults. Okay, and you can click on Archive. And so for this activity, it's not that big, and so it doesn't take that long to archive. And so what you'll see here is that it's going to produce just one file right here. Okay, and so this is the file that you want to move. Okay? And so now you can take the zip file and you can transport it, you can put it on a flash drive, you can email it to yourself, you can put it on Dropbox, and you can open up this file in ANSYS, later on. Okay. And so to open up this file later on, you need to open up ANSYS Workbench and then click on Import. And when you click on import and then you click on that compressed file, that's going to load up your project. Okay? And so it's a little bit of a convoluted way to move your files around, but if you're switching between workstations, switching between computers, this is kind of the best way to do it, just to make sure that you transport all your files. That's fine. Okay? All right. And so are there any final questions on this activity? Yeah.
When you go to, can you show again what you do after you click archive?
Yeah, so when I click archive, it's going to ask you for the name of the archive that you want. So let me just go ahead and overwrite it. And then it's going to open up this menu, and then you can just click archive right here. Yeah. So basically what this is asking is like if you want to save certain parts of the project. Yeah. All right, any other questions? Okay, all right. So I'll stick around for the next few minutes if you guys are still having troubles with the program, but that was our first crash course in ANSYS, and so that actually went super smoothly compared to previous years. So great job, everyone. Okay, and so I was telling someone else before the class, so we're gonna have ANSYS activities every other week. And so next week is going to be just 2 traditional lectures. And then week 3, we're going to have our next ANSYS activity. Okay, so you can kind of count on that schedule. All right, so thank you everyone for coming today. I'll be walking around to kind of meet with you guys if you want to talk. Have a great weekend, and I'll see you guys next week.
I think those are class round, so. So you can't really stay here that long. I'm trying to figure out this part. Yeah, I think there's another class, so.
Oh, okay. Yeah. So this might be. This is what I actually like to do. So if you click on this first one right I appreciate it. It's a little of an old. Oh, yes.
Honestly. That's a sad statement. Yeah, I get home at 8:45. Oh, that's so much lighter now.
I know it's here somewhere. Yeah, usually. You guys know you guys. Oh, not usually. It's okay. I do have one. He's just about ready to. He's almost done. Besides that,
I want to continue.
Oh, yeah. I mean, this one's probably not going to this kind of, more advanced projects later. And this final project in this class is actually what we use my ANSYS. So that one's going to be like a area of finite element analysis. That's usually the one that we work on.
That's fast.
Crazy.
No. Are you? Yes. Are you having one? Are you still teaching?
Yeah, some of the buttons might be different, but they're pretty consistent. The icons they keep the same. They might be in different
No, I'm just right. So, right, I have this thing. I have it archived that we just did, right?
Yeah. So that's what they have.
I want to import it. I tried to
So let's see what's there. Hopefully it's just.
I don't know.
Right, so then
See, the good thing about this particular project is that it's very fast. Exactly, yeah. So for a larger project. Yeah. Basically, everything is here.
Wait, what?
Oh, okay. Oh, okay.
I'm lost. I have lost my eyes. Even doing.
Yeah, it's just because we. I'm gonna do that. We went.
Your last chance.
And so typically. How religious is your? For the future. I would just. There's ways of what you think you want to create that you want to compare that. So most of the time it's actually not, because usually by this point, setting up the ANSYS actually. That's where most of the time. So by the time you load it, half on That's better, right? So they make the catch file with.
Actually, I should have, or I should talk about it. You said that you can't reopen it if you don't archive it.
Yeah.
I was trying to reopen it on this I saved it on. Yeah. Letting me import it or open it. Do you just open it? Save it on this computer and this location?
Yeah.
Do I need to open it like a normal?
If you're gonna be on this, you can do that.
You can just open it.
Yeah, but the archive is mostly for just move that project.
Oh, just so we tried importing it from our.
Oh, really?
Where we said it's like, no, it wasn't here, it's there or something.
So on that thing, for a while, at first.
Once, but then I have these two.
That's what you started.
We did that again.
Yeah.
Just change the name because I misspelled it.
I would probably do all, if you're gonna do that. I would do.
Yeah. Because I know this is the one that. So why would you just search it out? No, I want.
Oh, that's hard.
Yeah.
I can't read it.
Yeah.
I just don't have my glasses.
Yeah. I'm going to keep trying to figure out which files were those updated.
I can use them, really. You want like
Oh, yeah. Are you? Okay.
For what?
Yeah, so I actually,
What is it?
and I'm gonna, so the last year they did like the to expand the and then now.
You should do something with a revision of that.
So go ahead and send it in
Stop. Subject. Okay. So we get. One version.
Yeah, my father, so, yeah, like, as soon as you say this is one losing. Okay. Geometry was version, so it's like, well. No, it's not much.
Underscore another name. So it's like version 2 or version 1, your name, or initial, and then underscore my name. Okay.
Someone else. But you said most of them, mainly you guys all like. So even if necessary, maybe you violate the stop.
Is consistent.
Oh, no.
It's good, but if someone doesn't.
Somewhere. Oh, there is one. I think he's done with that, but I. Exactly.
So it's probably the sure Excel file, like, okay, I put my down to the file. Yeah, it's where it's.
Please do, because.
It's for delete and
No, it's okay. What does that simply mean? You know, whatever.
I'm doing it like my
Don't be afraid.
I'm not afraid. It's just-
Sure.
Oh, shit.
I essentially have whatever the location needs to be, right? You can't have. Here in this case, but essentially I have revisions. And then, yeah, it's like that, the actors, it's like those free. So you have like 3 or 4 red at once.
The first
Hey Gary, sorry about that.
that.